And so after we've added 1 to the number of lines, let's read the next line. Because remember I said that if you call read line, it reads the line and moves the read position from the end of the line here to the beginning of the next line and waits for you to call read line again. So if we call read line again here, what we are doing is we are reading this line here, Nana, right? And then the read line is going to move. After reading this line, it's going to move the read position from the end of this line to the beginning of this line here. And so when we call read line again, it's going to be a loop, right? It's going to keep iterating. When we call read line again, it's going to read the next line and move the read position from the end of that line to the beginning of the next line until we call and wait for us to call read line again. So after we've added 1 to number of lines, let's call read line again. So it's going to be the file object names file. Let's apply the function to it, read line. And once we read line, remember it reads the line and it returns the content, okay, of the line read. And so I'm going to store it back in line so that when this loop iterates, it's checking the next line each time, And so what we are doing here is when the program starts, number of lines is 0. We read the first line. So basically we read the first line, echo is stored here. Number of lines is 0. While echo, right, it was able to read it. While the number of lines is, while the content of this line is not an empty string. It's not an empty string. It contains a value, and that value is echo. And so in that case, this is not an empty string. Because it's not an empty string, it's going to add 1 to number of lines, meaning we found a line, a valid line, a line with content. We add 1 to number of lines, and then we call read line again and store whatever is returned in here. So when we call read line again, remember the read position, after reading echo, the read position will be here. And it reads Nana, and then Nana will be stored here, and it checks to see is Nana, if it's checked to see if Nana is not equal to an empty string. It's true, Nana is not equal to an empty string. It contains characters, Nana, right? And so number of lines is increased by 1, which becomes 2, meaning we've found a second line that is not empty. And then once you're done with that, call the read position again. Remember remember the second time we call read line, after reading Nana, it moves the read position to the beginning of the next line and waits for us to call read line again. And so when we call read line, it reads LC, right? And then it moves the position from end of LC to Pinyin. That's my twin brother, by the way. And when we call read line again, it reads the line and moves the position from the end of that line to the beginning of that the next line. So that's how read line works. And because it's a loop, we are basically reading all the lines. And when we get to the last line, after reading Asante, right, and storing Asante in line, it's going to move the position here, the read position, and wait for us to call read line again. So when it calls read line again, because there's nothing here, it's going to return an empty string. And so line will hold an empty string. Now it's going to check while the content of line is not equal to an empty string, right? This loop is only going to run if the content of line is not equal to an empty string. But if you read the very last, empty space over here after Asante, if you read the very last empty space over here, line will contain an empty string. And so this loop will only run when line is not equal to an empty string. But because line will be equal to an empty string, the loop will stop. That means that you've reached the end of the file. All right, and then once we are done with this while loop, by the time this while loop is done, we'll have number of lines. We'll have the number of lines of the file. And so in that case, all we have to do is print it out. Let's just go ahead and say the file. Let's use a string and say that the file has, and then I'm going to pass these values in this print function as arguments. So the file has, and I'm going to use number of lines, the number of lines variable, the content of it. And then I'm going to pass another argument. So the file has this number, this number of lines. And then I'll use another string and say lines. I don't need a space here because by default. All right, so when you pass in arguments into the print function this way, right, by default they are displayed with a space separating each of the arguments. And so this is going to read as the file has space, the value of number of lines, let's say it's 4, assuming it's 4, it's going to be the file has 4, and then space lines, right? By default, it's going to separate these with spaces, these arguments with spaces. So for the most part, we are done. We'll add exception handling, okay, to make sure that, just in case the file doesn't exist, we don't want our program to crash. So we'll add exception handling in a moment, but let's test it out. Let's test this out. Now, if this is the main functions, and so if I run the program the way it is right now, nothing will happen because I've only defined the function. Remember, it's a function, and so if I want the code in there to run, I need to call the function. So if I save this program, nothing is going to happen, and let's just see that. So I'm going to save selected files. I'm going to go to the desktop, the same folder where I saved the file, the text file, and this is called item counter, right? Okay. In this same folder where I saved the the txt file, I'm going to save this program as item counter.py over there. Now I saved, because I saved the file in the same location as where the program is, I just have to type in the name of the file. But if the file was somewhere else, I need to type in the entire path of where the file is, of where the text file is. If the text file was somewhere else, I need to type in the entire path of where the text file is here, so that the program can have access to the file. All right. But because it's in the same location, the same folder, I type in just the name of the file with the extension. Okay, with extension, and it will work. Okay, so let's now call it, because now when I run this program, nothing happens because we haven't called the main function. So now I'm going to go ahead and call the main function by its name. And so when I run this now, oops, we have an error. So let's work with that. Name number of lines is not defined. Okay, and so over here I define number of lines with a capital L. You can see it here. But over here, I did the same. I did the same thing. I used capital L. But over here, I use a small l. So it doesn't know what this number of lines is. So I need to change it to capital L so that it matches this one, right? It matches this. Okay, so I'm going to stop it and run this again. And now it says the file has 9 lines. Let's check to make sure it's correct. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's correct. And so let's delete a few of them. Now I'm leaving 4 lines in here, right? I'm going to save it, Control S, or Command S on Mac. I'm going to save it, and I'm going to run this again. And it says the file has 4 lines. If I remove everything from the file, save it, and I run it, it says the file has 0 lines. If I undo, I still have 9 lines, 9 lines here. Make a copy of all the lines, paste it again, and paste it again, and paste it again, and paste it again. I should have 45 lines now because I pasted it 5 times, and 5 times 9 is 45. Save it and run it, and now it says the file has 45 lines. And so it's working. Try a couple more. Let's just do. Let's just leave 1 in there. Okay, so I'm going to remove all that and remove all that and leave Elsie. Yeah. That's my girlfriend, by the way. And save this, and I did that on purpose, just for fun, and also because she's my girlfriend. Sorry, that was just by the way. Save it. I have only 1 line here, so when I run this, and the file has 1 line, right? I can just do this here. 1 line or lines, depending on how many lines in there. So it has 1 line. Okay, so we know this is working, right? Let me take this back to where are you? Okay. Okay, and so now the program is working, and that's fine. Now let's work on exception handling. Now, what if I type in the name of what if I type in the name of the file wrongly, or what if in that folder, let's go here in that folder here. Oops. Let's do the desktop. What if what if this file wasn't in this folder, or you removed it for some reason? Let's say I deleted the file for some reason. What if I did that? Then we're going to have an error. But let's just change the name of the file, right? So that when it tries to look in this folder for names.txt, it can't find it. Sorry, I'm going to change it to name.txt, right? So that So that when let's change it to name.txt, or let's just do even na.txt. So when it tries to look into or look in this folder to find na.txt, it wouldn't find it. There's a file called names.txt, right? But not na.txt. But oh, by the way, this is a txt file, by the way, but it's just not showing the extension well. Let me go ahead and command I info to show the extension. Don't hide the extension. Okay, now show it. Yeah. Okay. So now we can see the extension. Names.txt. And so now there's a file called names.txt, but there's no file called na.txt. What's going to happen when we run the program? It's going to crash. When I run the program, you see that it's already crashed and said that, well, basically what happened was it threw an exception and said, no such file or directory. We don't want this to happen to the user. We want a nice message to be displayed to the user, because this is really what an error message being displayed, for behind the scenes, kind of. So we want something to display to the user instead of this the program crashing or throwing an exception. Let's handle it. And so I'm going to wrap a try statement around. I'm going to wrap a try except statement around any statement that has the potential. Okay, that has the potential, not necessarily, not necessarily any statement that's going to cause an error, but any statement that has the potential to cause a certain kind of exception. Now this exception is really called an IO error, like an IO error. But if you're not sure of the name of it, you can just generally call it exception, right? But let's just do this. Try. I'm going to wrap a try statement around this line, and then I'm going to have an except statement right after that. And so all I'm saying is try to run this program. Try to run this line. Okay, and run the program fine, all right, except when this has a problem. And if it has a problem, then I'm going to create a print statement and say that the file does not because I wouldn't know exactly what happens. I'll say there was a problem opening the file, right?